Virtual storage system. The virtual storage system, also called virtual memory system, is a system that provides a logical address space that is larger than the capacity of the actual main memory. Programs are divided into several parts, and only the parts that are needed for processing are loaded into main memory. The parts that are not needed are put into an auxiliary storage device. This makes it possible to execute large programs in a small amount of main memory. In order to realize this virtual storage system, language processors and linkers, which can divide programs into multiple program modules automatically or based on programmers' command statements, are required. The virtual storage management program is also required for loading the necessary modules into main memory for processing and saving the modules that are not needed into auxiliary storage. In addition, it is necessary to know which program module should be loaded into which location of main memory. The address of that module in main memory needs to be computed. In addition, a function to detect the module that is not present in main memory when accessed and to notify the OS is also needed. This is done with the Dynamic Address Translator, DAT. This needs to be implemented by hardware. One. Segment system. The segment system divides the program into multiple modules called segments, such as main routines, subroutines, and data sets, loads the needed segments into main memory, and then executes them. The logical locations of instructions and data, logical address, the location within the entire program, are expressed with segment numbers and relative addresses in the segments. With regard to the execution of the program, the DAT mechanism computes the effective address from the relative address in the segment, and it becomes the target for arithmetic operations and fetching instructions. The segment table manages where each segment is located in the main memory. The segment table is referenced in computing the effective addresses. When it is found that the target instruction word, or the segment that includes the data is not in main memory, the DAT mechanism generates an interrupt and activates the OS. Then, the OS rolls in the applicable segment, and processing is resumed after the segment is recorded in the segment table. If there is no free space at this time, the OS rolls out unnecessary segments into the auxiliary storage and rolls in the applicable segment. Two. Paging system. The paging system divides the program into multiple fixed-size, 2 kilobyte or 4 kilobyte, modules called pages, regardless of the logical structure. Numbers 1, 2, 3 are allocated to them in sequence from the top module. When set, these numbers do not change, so it is called static relocation. The location, logical address, of each instruction word and data is expressed by the page number and the address on the page, displacement in the page. The main memory is divided into pages, page frames, of the same size, and page numbers, 1, 2, 3, are attached from the top. The pages needed for the execution of the program are loaded from the auxiliary storage into free page frames in main memory. The location where they will be loaded is determined at execution time, so it is called dynamic relocation. The system, which loads the needed pages into main memory, page-in, is called the paging system. When there is no free space in main memory at page-in, unnecessary pages are paged out to the auxiliary storage. In addition, the auxiliary storage used in the paging system can have pages executed by loading the pages into main memory, so it is called virtual storage. The role of the DAT feature is to compute the effective address from the logical address of the instruction word and data at the time of program execution. The address translation is done using hardware, so it is very fast. Also, if the page that includes the target address is not found in main memory, the DAT feature generates a page fault interrupt and activates the OS. The needed page is then paged in. There are two typical methods for selecting which page to replace with a new page. Page replacement. 1. FIFO, first in first out, method. In the first in first out method, the page that was paged in at the earliest time is paged out first. 2. LRU, least recently used, method. The page that has not been referenced for the longest period of time among the current pages is paged out. A virtual storage management program is responsible for dividing the programs into pages, paging in, and paging out, and in addition, the DAT feature is for computing the effective addresses of the instructions. In the paging system, the user does not have to worry about segmenting the program with careful regard to its logical structure. In addition, the user can develop and execute programs using virtual storage space that exceeds the capacity of main memory.